Hi everyone, this is Alex, and in this video I'm going to practically explain you how to use branched path tracing in cycles in Blender. You might have heard of this way of rendering in cycles, which can be chosen in this part by choosing branched path tracing, and probably just few of you are using it because many times when you try to switch from path tracing to branch path tracing and use approximately the same settings, you get absolutely different result, or at least in some areas, and you don't know what to do with this. And when you refer to Blender documentation, you get just the simple description saying that whenever numbers you choose, if the result is the same, which is the same with this path tracing, you get the same result, but in practical situation it is not so. So let's try to understand how this branch path tracing works, and we'll just use this simple scene which I have here, just a simple cube. And first we'll start with just diffuse environment. We'll see some rules in this way, and later we'll switch to diffuse plus glossy environment, and later we'll use principled shader, which uses Fresnel effect by default. So we'll see how Fresnel effect changes the situation, and finally we'll get some practical example and we'll see what benefits branch path tracing gives us. So let's get started. First of all, we have this simple cube, and you can see that it has only diffuse material. The background also has diffuse material. So we are going to we'll make a few renders with certain settings, and after that you will see what's really going on there. First of all, we'll make the first render with only 50 samples. Alright, so let's make the first render with the path tracing with 50 samples. I forgot to switch on this screencasting. Alright, so this is it. This is our test image, and we will compare other images which we will get with this branch path tracing with this default image from path tracing. So the thing is, we need to understand how these numbers for this path tracing render correspond or relate with these numbers here, and how to choose these AA samples or these numbers here. Just remember, we have this render with 50 samples, so we will maintain this number of samples in all the next renders we'll do. We'll only change these numbers, AA samples and these diffuse samples, to see what's really going on. So in the slot number 2, we'll make the first render with 1 AA sample and 50 diffuse samples. So we will get the total number of samples 50, and so let's see what we get. As you can see, the difference is huge. Although this picture with path tracing has 50 samples, and in this picture with branch path tracing we also get 50 total samples, which follow this rule explained in the documentation, but this rule does not work. So let's try to make another render with 2 samples here, 25 samples here, keeping this 50, and let's see what's going on. As you can see, as I switch from one slot to another, the picture is changing, the situation is changing, and it's improving. Okay, so I will make further renders changing these numbers from 1 to 50 for AA samples, and from 50 to 1 for diffuse samples, keeping the same ratio, keeping the same ratio of 50 for diffuse samples in total, and we'll see the difference. Okay, this is what we got. We have several slots with several renderers, and as you can see in the first slot we have a render with path tracer with 50 samples. In the second slot we will have, this is it. We have a render from branch path tracing with a 1 AA sample and 50 diffuse samples. Third slot, 2 AA samples 25. Fourth, fifth, sixth, seventh. As you can see, there is a big difference. All these renders, they have the same total number. Like for this second slot, it has 1 AA sample and 50 diffuse. So this total number of samples is all the same, and it equals this path tracing. But as you can see, the difference is huge between the first one and the second. But let's analyze these renders, because they will give us a very important rule we should follow when using branch path tracing. The first thing which you may notice that when you increase the number of AA samples while decreasing the number of diffuse samples, but maintaining the same number of total diffuse samples, you get better noise picture in the directly lit areas. For example, in this face of the cube. When we increase this AA number, we get rid of this noise. Another thing which you may notice is this anti-aliasing. The bigger the AA number, the better your anti-aliasing situation is. So this result on the 7th slot is with 50 AA samples and you have no aliasing. And I would recommend not go below 20 AA samples ever. Because, for example, for this 5th slot, this aliasing situation is more or less okay, but 10, 15, 20 AA samples, you should not go below than that. Another important thing which you may notice is timing. When you increase the AA number of samples, you increase the time. So when this anti-aliasing number of samples is low, you get also low times. But when you increase this number up to the initial number of path tracing, you get almost the same timing. And you also see the difference in quality of shadow. When you increase the AA sample number, you improve the shadow quality. And when we get the situation when the number of AA samples equals the number of original path tracing samples and diffuse number is 1, only in this situation we get the same result. As you can see, the 7th slot, the 1st slot, 7th, the 1st. There is almost no difference between these renders, whereas when using other combinations of numbers, the difference is obvious. But let's dive deeper and see what's going on in our passes and why this difference is there. First of all, let's look at direct diffuse. This is the 2nd slot, 3rd slot, 4th, 5th, etc. As you can see, this combination of these numbers directly affect diffuse direct pass. Okay, so the noise you get and the quality of shadows, anti-aliasing, all these things, they improve when you increase AA samples number. Whereas diffuse number will not give you any difference. For example, on the 3rd slot, I have a render with 2 AA samples and 25 diffuse. At the 8th slot, I have the same AA number with 100. This is like 200 total diffuse samples, but let's see whether there will be any difference. 3rd slot, 8th slot, 3rd slot, 8th slot. In this case, look at the time. It's almost 30 seconds, whereas originally we had only 8 seconds, and there is no difference. So again, if you want to improve your direct pass quality, increase your AA samples number, but not this diffuse samples number. But let's see what's going on in indirect pass. This is the second slot, third slot, fourth, fifth, seventh. There is no difference at all, absolutely no difference. It means that this total number of samples only affects this indirect diffuse pass. And no matter which numbers you choose here, if the ratio is the same, you will get the same indirect lighting. But if we take this third slot and the eighth slot, where we had no difference when looking at the direct pass, if we look at indirect pass, we can see clear difference. This 8 slot image has larger amount of total number of samples. That's why it has a better indirect diffuse pass. Third 8, third 8. But if we compare diffuse indirect pass for path tracing and branch path tracing, you will see also very little difference. The difference is mainly in the pattern of the noise. And I would say that in case of branch path tracing, the amount of noise in indirect diffuse pass is a little bit less than in original path tracing. To sum up, if you want to achieve with branch path tracing the same result as with path tracing, you have to use the same number which you use with path tracing in AA number of samples and use just one for your diffuse. Thus you will get the same result, and actually it will be a little bit better and it will be a little bit faster. But this all relies only to diffuse environment. So let's see what happens when we use diffuse plus glossy environment. Okay, now let's see what happens when we introduce some reflections into our scene. So in this example we have the same background, the same objects. We have monkey instead of cube just to better receive reflections. And materials are pretty simple, just diffuse shader mixed with glossy shader, from the same for the background. Everything as usual, no Fresnel for now. We only need to understand what happens in glossy passes when we use branch path tracing. So as usual, let's make the first render with 50 samples. Okay, this is our reference shot. As in the previous part, we'll keep this shot in the first slot, and for the second slot we'll take branch path tracing, 1 AA sample, and 50 samples for diffuse, 50 samples for glossy. And let's see what we got. Okay, this is very similar to what we got in the previous part, but again we'll have to go deeper into each pass and to combine different combinations of these numbers to really understand what's going on. So let's make further renders. Okay, now we have reflections in our scene and our test renders are ready. So let's see what we got. First slot, path tracing, 50 samples. Second slot, branch path tracing, 1 AA sample, 50 samples for diffuse and for glossy. Third, fourth, fifth, sixth, seventh. There is a difference between them, but in comparison with the first part, where we had no difference between the second slot, the first slot and the seventh slot, we have difference this time. The reflection in the seventh slot, which is for branch path tracing, is much clearer. It has less noise than original path tracing but the same amount of samples. So let's try to understand what's going on and what is different in this case, where we have not only diffusion but also reflection or glossy in the scene. So let's try first check our direct diffuse pass, branch path tracing, 1 AA, 50-50, third slot, fourth, fifth, sixth, seventh. Everything is just the same as it was in the previous part, no difference. Let's check diffuse indirect. Second, third, fourth, fifth, sixth, seventh. No difference between all these renderers because the total number of samples is the same. It was 50. So it's just the same as it was in the previous part for diffuse environment. But let's take a look at glossy passes. Second slot, glossy pass, branch path tracing. Third slot, fourth, fifth, sixth, seventh. We can see similar tendency as it is in diffuse direct, which means that increasing the AA samples number, you improve your direct glossy pass condition. You get rid of your noise and you improve your anti-aliasing. Alright? So let's check our glossy indirect. Second, third, fourth, fifth, sixth, seventh. Again, there is no difference. So just as in the previous part, this glossy indirect pass is only affected by the total samples number and not by the combination of these numbers. So for example, in the third slot, we had the total samples number 50. It was 2 AA samples and 25 for diffuse and glossy. In the 8th slot, we have a render with a total number of 200. So we can see that this is the third, this is the 8th. So indirect glossy pass is much better when the total number of samples is larger. But the render time is also increasing. And again, as it was in the previous part, this total number of samples does not affect direct glossy pass. This is the third one, this is the 8th. Third, 8th, there is no difference. But let's check the visual side of what we got. This is the path tracing with 50 samples image, and this is branch path tracing, or even this in the 7th. Why is there a difference in this reflection? Why did branch path tracing take longer in comparison with path tracing? And why did we get a better result in the reflection? We couldn't get the answer in our passes because the answer for this question lies in how shaders work. For example, in this particular render, in the 7th slot, we have a picture which had 50 AA samples and 1 diffuse and 1 glossy sample per each AA sample. It means that when rendering, cycles used 50 diffuse samples and 50 glossy samples. Whereas when you use path tracing and when you set 50 samples, it does not mean that it will use 50 samples for diffuse and 50 samples for glossy. It all determines by the material. The basic principle is that when we create some plastic material, for example, we use mix shader, which mixes diffuse and glossy in some proportion. In this example, we have 90% of diffuse and we have 10% of glossy. It means that when the cycles shoots the rays from the camera into the scene or into some object, when these rays hit this object, which has, for example, this particular shader, there is a 90% possibility that this ray will bounce off as diffuse ray, and there is 10% possibility that this ray will bounce off as a glossy ray. It means that if you shoot 50 rays into your scene, then about 5 of them only become glossy rays and 45 of them become diffuse rays. It means that in this particular scene, in the first slot, where we had this path tracing and used 50 samples, we get more or less the same result in diffuse channels. But the result which we get in glossy channels is so much different between the first slot and the 7th. The same amount of samples, but the difference is huge, both for glossy direct and for glossy indirect. This is path tracing, this is branch path tracing. That's why, even though you can see that branch path tracing takes longer for rendering an image, you cannot directly compare it with path tracing with the same amount of samples, because the real amount of samples is different. So this example actually shows how great branch path tracing is, because in this image, this render from the 7th slot, 50 AA samples were used to produce this image, and 50 of them were glossy samples. Whereas in this image, when we used path tracing with 50 samples, only 5 samples from these 50 were actually glossy. That's why these reflections are so ugly. So if you wanted to have the same quality of reflections when using path tracing, you would have to use not 50 but 500 samples in order to get these 50 glossy samples just to clear these reflections. But if you have just 90 seconds for branch path tracing to get this result with these 50 AA samples, you can imagine how much time it will take to produce an image with the same quality of reflections but with 500 samples. And even if you use these 500 samples and your reflections will become the same quality as they are in branch path tracing, you will waste lots of diffuse samples to clear the parts which are already clear. So you will waste your time and your render will suffer a lot in terms of optimization. So now let's see what happens when we use physically accurate materials with Fresnel. Okay, finally, when you use physically based materials, for example, in this case I use Principled Shader, which is a part of newly coming Blender 2.79, but you can get it in the experimented version from Blender side. So I have very basic materials for the monkey and for the background. When you use physically based materials, it becomes a bit complicated in terms of determining how many rays will bounce off as diffuse and how many rays will bounce off as glossy. Because in the previous example we had a fixed ratio determined by the mix shader, which tells us that 10% of all the rays will bounce off as glossy and 90% of all the rays will bounce off as diffuse. Whereas when you use Principled Shader or any other physically based shader which has Fresnel effect, this ratio of how many rays are glossy and how many rays are diffuse is determined by the angle or the shape of this object. And at the grazing angle, you will get more glossy rays, and at facing angles you will get more diffuse rays. So spreading of these problematic areas or noisy areas will very much depend on the shape of your object. When you use physically based materials, all the rules which were mentioned previously will be applicable here as well. For example, this is path tracing, this is branch path tracing. Both renders 50 samples, and as we mentioned before, by using branch path tracing you will gain in quality and you will get increased render time. The same thing with physically based material. The first one is path tracing, the second one is branch path tracing. Again, you gain in quality and you have increased render time. The only thing I'd like to mention here is that although this Principled Shader, even if we take only path tracing renders, the first and the third slots, tends to produce more noise even though it takes more time to compute, especially if we take diffuse direct passes. This is Principled Shader, this is diffuse plus glossy shader. So Principled Shader produces more noise. But if you compare two results of the second slot and the fourth slot, which are both branch path tracing renders, and the second is from Principled Shader and the fourth from diffuse glossy shader, you can see not much difference. It means that with traditional path tracing, Principled Shader tends to produce more noise with the same amount of samples than with the simple diffuse plus glossy. But when you use branch path tracing, you will see no difference. So basically, when you use branch path tracing, you should follow a very simple workflow. First of all, you have to decide which number of AA samples is enough for you. To do this, you should analyze your shadows, your edges, and your direct passes. your diffuse direct pass and your glossy direct pass. Once you're happy with the result, you should stick with this number and then check your indirect passes. If the amount of noise is too high for diffuse indirect, you should increase your diffuse sample count. If the amount of noise is too high in glossy indirect, you should increase your glossy samples count. This is how you can improve your timings to optimize your render depending on the scene, and this is what makes branch path tracing so important in some particular cases. The video is already getting too long, so I will not cover all the other settings for transmission, means for transparent materials like glass, or subsurface like skin, or volume like smokes. But the principles will be the same for these materials as well. So this is all about theory, and I will probably make a video with a real-life example, with a kind of production scene, where I will use branch path tracing and will show you how beneficial it can be. So I hope it was helpful, and please excuse my English. English is not my native language, and it's a bit difficult to talk to no one, just to the microphone. But anyway, thanks for watching. Bye.